My name is Parker Landon. I'm a junior here at Embry-Riddle. I am pursuing a dual major in computer engineering and space physics. Today I will be talking about my research and give you a little bit of insight on interferometry. So the first thing we're going to talk about is the types of lasers. So many people have like the normal laser, the household laser, the little red dot laser. You might be able to see, there you go. It is a class 2 laser, and class 2 and below are actually really safe and mostly used for household items. But there's higher classes of laser. So this laser is a class 3 laser. So it is actually very dangerous. It's not good to look into it. No laser is good to look into, but these are especially bad because they can really hurt your eyes. So while we're working with these lasers especially, or even higher classes where we can go into a class 3B or even to a class 4, we have special goggles to help us protect our vision. So I'm going to actually shoot this and you'll see how bright it is. And I'm going to actually give you a comparison of these two right now. So we have this black matted surface which will be used to actually help not reflect the light directly back at us. So this is our normal household laser, class 2 laser. And then this is our class 3 laser. You can see it's much brighter than our class 2 laser, which is really, really dangerous to look into. And even the reflection off of this is actually pretty dangerous. You might even be able to see it reflect onto the board. If I can get it there, you can see it right there. So it is super, super bright. Now that we talked about laser safety, we can start talking about laser interferometry. So for laser interferometry, we like to think about it as more of a type of measurement. So if we think about a laser, we usually think it's very precise and very focused. If we look at this example, I'm resting my hand on the desk, but if I start moving my hand, we can see the laser pointer actually moves. So this is kind of what interferometry means. So we're focusing on the movement of our laser. A really good example of this is actually the LIGO project. So if you've ever heard of LIGO, it is about gravitational waves and how we've been able to find and actually see what they look like. So if we think of these tubs of Jell-O as space-time, we can actually use our lasers to look through space-time. You can see our laser dot right there. It's kind of hard to see through this because this laser is too weak to actually see through. So we're going to actually put on our safety glasses and test with the class 3 laser. So we got our safety glasses on, and we're going to look through right here. See, that's much brighter. We can actually see the laser through the Jell-O. And if we look through here, same thing. Okay, so when I say space-time, well, you see that it's very movable, right? If there's a huge, big explosion, like, let's say, 2 neutron stars collide to each other, or 2 black holes collide to each other, that's going to create a lot of energy in what we call a supernova. So let's pretend this tiny little jack-o'-lantern is our supernova. So what happens when a supernova happens? It shakes all of space-time. It jiggles all of space-time. So when we're focusing our laser, like I said before, we're going to rest it and make sure that it doesn't even move on the other side. But when space-time is shifted by a supernova, we can see our laser will actually move. It's a little hard to see. You can kind of see the flicker. Isn't that cool? So now that I've talked about laser safety and a little bit of what interferometry is, I can bring you into our lab. So this is our laser. It is a class 3B. You can see it's very dangerous. It's very small, actually. It actually requires a key to even turn on, if you can see right there, which means it's completely off, and we have what we call an aperture, which is closed currently. So even if the laser is on, we can still close the aperture and make sure that the beam does not go through our system. Before we even put the key into the laser, we have to ensure everyone in the room has their goggles on, and that we have turned on our laser light outside, as well as make sure all of the doors are closed, and this laser is encased into this room and this room only, even if there is a reflection or diffraction, anything like that. We want to protect everyone in the lab. We also have these walls that prevent stray beams from going out. Just another precautionary thing, especially for when we're working at the computer, we have a higher wall. So now that we've seen what the laser looks like, we can actually start looking at what my job is for my project. If you look right here, this tiny little box is full of a circuit board that I made and I soldered myself. This is what controls everything that goes into the laser. So it is important to keep our laser what we call cold. So we look at what the laser is outputting. We see if there's anything that we call noise, like if there's a vibration that might change what the beam looks like. This box will actually correct those vibrations or the amplitude of the strength of the laser. I just want to thank everyone for listening to my research today, and I hope that you were able to learn a little bit more about laser interferometry. Thank you.